On page 67, this is where they started with identifying functions. Study the example problem showing how to determine whether a relationship is a function and then solve problems 1 through 7. In the example, it says to describe the relationship shown in each table. Is the relationship a function, and explain. So table A, we have hours as our input and cost as our output. Our hours are 1 through 5, and our cost is 3, 6, 9, 12, and 15. The question is this a function? It is a function, okay? The relationship is a function because there is only one output for each input. Okay, we only had each input one time, so there was no opportunity for anything to duplicate. So it is a function. Table 2, similar. We've got number of weeks as our input and plant growth as our output. And we have 1, 2, 3, 4, 5 as our inputs. Again, nothing is repeated, and it is a function because there is only one output for each input. Okay, so both of these were functions. There were just two different types of functions. Now, number 1 says, can you represent either of the functions in the example problem with an equation? Now, in order for a function, okay, if one of these is going to be a function, or no, not if it's a function, if it's going to have an equation, we've already established that they're both functions. If it's going to have an equation, it has to have a pattern, a repeatable, predictable pattern that works every time. So when we look at these tables, you are looking for some form of mathematical pattern based on inputs and outputs. What can we do to the inputs to get the outputs and it work every time? So 1 and 3, 2 and 6, 3 and 9, 4 and 12, 5 and 15. Is there a pattern? Yes, there is a pattern. The pattern is we are increasing our cost by $3 for each hour. Okay, so there is an increase, and the fact that it is increasing is important. There is an increase of $3 each hour. Now, as a constant of proportionality, like they just talked about on the last video, that would be it, okay, the $3 per hour. So if we wanted to write an equation, our output, y, is equal to the constant of proportionality, or the rate of change, times the number of hours. It's a repeatable pattern, and we can represent it with an equation. Now, table B is decreasing, but look at the numbers and look for a pattern. 1 and 4, 2 and 3.25, 3 and 2, 4 and 2, 5 and 1.75. Now, it's decreasing, but is it predictable in the amount that it's decreasing? No. Guys, there is no pattern to this. This is random. So we cannot write a function, or we cannot write an equation. Okay, there is no equation that will represent this one. No pattern, no equation. Let's just write that down. No pattern, no equation. Number 2, suppose you reverse the inputs and outputs in table B. Okay, this was table B. If we switch the inputs and the outputs, they want to know, would this relationship be a function? So our new inputs, our new x's, would be 4, 3.25, 2, 2, and 1.75. Question is, would it still be a function? The answer is no. And the reason would be because the input 2 has multiple outputs. Okay, each input is only allowed to have one output, and this one would make that not a function. Number 3, the table shows the number of concert tickets sold by 5 students. Is the relationship a function, and explain. Student number 1, 2, 3, 4, 5. Tickets sold 12, 18, 12, 22, 16. Is it a function? Yes. Okay, to determine if it's a function, we're going to look at the inputs. Okay, the inputs was the students. 1, 2, 3, 4, and 5. None of those were repeated, which means that each one only had one input. If I'm student 1 and I sold 12 tickets, okay, I can't turn around and go, oh, I'm student 1 and I also sold 15 tickets. Right? They sold one amount of tickets because whoever you was telling this to would have been like, okay, well, honey, you need to add 12 and 15 because that is your total. Okay? It's not 2 outputs, it's just the one. All right, so each input has only one output. It's okay that 2 different students both sold 12 tickets. It's just not okay for one student to have multiple outputs. All right, they gave you another vocabulary word here. Function, a rule that produces exactly one output for each input. All right, on page 68, these number 4 and number 5, you're actually going to make a graph. Now, I cannot stress to you how important it is that you learn to do this properly and neatly, because I have to be able to read it. If I can't read it, then no one can read it, and it's useless. The table shows the number of calories in different servings of blueberries. We have our inputs as the number of servings. Now, I told you that your inputs are your x's. The inputs go on the x-axis on a graph, which is going to be horizontal across the bottom in this graph because it's a quadrant 1 graph. Now, we have to show our inputs of 1 through 5. Now, you could go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, or you can spread it out so that your graph is a little bigger. I'm going to spread them out. I'm going to skip a space in between. 1, 2, 3, 4, 5. Now, for my outputs are the y-axis. So here's my outputs, and it is my y-axis. That's the vertical one. Now, I've got to make it all the way to 105 for this graph. Now, I've got 10 grid marks. If it was just 100, I could count by 10s. But since it is so close to 100, I'm still going to go by 10s, and I'm just going to imagine that there's one more grid mark above it. Or you could draw another grid. I'm going to go 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, and then my imaginary 110 at the top. Now, I have to label these axes because the way it is right now, my graph has numbers, but it has no meaning. We need to also give it meaning. My x-axis was the number of servings, and the y-axis is the number of calories. Everything needs to be neat and labeled. The next thing it says to do is to plot the ordered pairs on the graph. 1 serving of blueberries is 21 calories. That's going to be just a smidge above the 20 mark. 2 servings is 42. 3 servings is 63. 4 servings is 84. And 5 servings is 105. Number 5 says, explain whether the relationship is a function. Now, you've got 2 options for determining if this is a function. You can look at your table to see if any of your inputs have been repeated. They were not, so it's a function. Or you can use the vertical line test on your graph. If you're going to make a graph, you might as well use it. So when I take my pencil vertically and cross my graph, I'm touching one spot here, one spot here, one spot here, one spot here, and one spot here. As long as my pencil only touches one point at a time, it is a function. So yes, it is a function. And then it says, can you represent the data with an equation? Was there a pattern to this data? Yes, there is a very clear pattern. Look how nice and neat and evenly spaced my graph is. That should be your first hint that there is a pattern. Now, if you look at your y's, 21, 42, 63, 84, 105. How am I getting there? I am increasing by 21 each time. Now, I need to know, how do I get those answers by using my x's? Well, if my constant of proportionality, my change, is 21, I've got 21 times 1 is 21. 21 times 2 is 42. 21 times 3 is 63. 21 times 4 is 84. And 21 times 5 is 105. So my equation, yes, I could write an equation. My calories, or my output, is equal to 21 times my input, which is the number of servings. Now, if you prefer x's and y's, my output is y, and it is equal to 21 times the input, which is x. Either of those equations are correct. I don't care if you use p's and q's. Two variables, one of them is multiplied by 21 to equal the other. Number 6. Substitute the values into the equation y is equal to x minus 3 to complete the table, and then state whether the equation represents a function and explain your reasoning. Now, in terms of inputs and outputs, the output is equal to the input minus 3. X is the input, y is the output, minus 3 is the function. Remember, the function is what operations happen to the input to give me the output. So I'm going to take my inputs, negative 2 minus 3 is negative 5. Negative 1 minus 3 is negative 4. 0 minus 3 is negative 3. 1 minus 3 is negative 2. And 2 minus 3 is negative 1. Does it represent a function? Well, if I look at my inputs, none of them were repeated, which means each one has a unique output. So yes, it is a function. Yes, it is a function. Because each input has only one output. Okay, each input has only one output. Number 7, complete the table below to show a relationship that is a function that you haven't used yet. You get to make up your own function. It just has to be something you haven't used yet. Be sure that you can represent your function with an equation. So they want us to write a function, create a function, and that function has to have a pattern so that we can write an equation. Now, this is really easy to do if you want to start with your pattern. Okay? I'm going to say that I am selling books for $6 each. Okay? They're $6 each. So one book is $6. 2 books is $12. 3 books is $18. 4 books is $24. And 5 books is $30. Now, my table is new. We haven't done this one yet. It is a function. Notice none of my inputs were repeated and all of my outputs are unique. And then they wanted us to write an equation. So my output, the cost of books, is equal to $6 per book or input. The relationship is 6 times the input gives me the output. Probably not the best wording, but it's okay. And that is it.